This is Algebra, College Algebra 1105. We're working on inverse functions. We're going to do 4 separate sections of inverse functions. Okay. So our first step is the relations. It's pretty simple. You take a point, each point coordinates to the graph, and we're going to find the inverse for each relation. So these are all going to be coordinates on the same graph. And what we do is we just swap the x and y values. So your inverse relation for this set is going to be, for the first part, would be -3, 1, which is just swapping the x and y value. And you do that for each part of the set. So the second would be 3, -2. 1, 5, and 4, 6. Cool?
Yeah.
Awesome. All right, so for the second part, to find the inverse of a function, this one is in the form of y equals mx plus b, but it could be in any form. What you do is you swap your x and y. Pretty straightforward. So in this case, we would put x here and have 3y plus 2, and then solve for y, because that'll give you your inverse. So we have, I'm going to go ahead and bring my x over and my y over here. So we have 3y equals -x plus 2. Okay. Divide by 3 to get y by itself. And your inverse function is -x plus 2 over 3. Just to check, make sure that's right. And that's pretty much all you have to do in order to find the inverse of a function. And then when you graph that, which we'll do in a little bit, you'll see how it is the opposite and flipped. So over here, verifying inverses. So this is where they give you your original function and the inverse of the function. And you're going to verify that they are inverses of each other. So how you do that is you would swap the x and the y and make sure that it comes out to be what the other one's telling you it is. So in this case, we would rewrite this as y equals x plus 6. Okay, that's this one. F of x is y, and g of x is y. Okay. So we're going to get this back in order. Sorry, we're going to swap the x and y. So we know x equals y plus 6. So in order to get we have -y equals -x plus 6. Y needs to be by itself if it has a negative, and if not by itself, we divide by -1. And we get right over here. Y equals, the sign changes for each one, x minus 6. And that checks off. That's just verifying that the information is correct. I'll try to trick you up if you get any of these questions. They'll make it so it's not correct and it's not so easy, and you're just going to go, this does not equal this. Okay. Oh, larger? All right. For the graphing, you're basically going to be taking this information and computing it to the graph. So if you have a point on your graph, you're going to take the inverse of that point. So here we have -1, 0. Here we have 1, -1, 0. And here we have 0, -1. So those are 3 definite points on our graph. So we're going to take the inverses of those, which is going to be 0, -1. Right over here. 0, -1. Center, -1, 0, and 0, 1. Okay. I'm going to do this inverse graph here. So we have a point at 1, 1, and there's the other one at -1, 0, and at 0, 1. So our inverse of the parabola that goes up is going to come on its side. So it has flipped. So it's the opposite, which is down, and then inverse is this way. It flips on its side. Okay? So for this example, we really only have one point that we're sure of, which is 0, 3. Now, from this, we can infer an mx plus b, y equals mx plus b, and we can see where our slope is. It's a little bit easier to see. 1, 2, 3. It doesn't give me the intercept for the x-intercept. So we're not going to worry about the x-intercept, but it does have a slope of -2. Sorry. -1/2. Yeah. So our m value is -1/2. And our y-intercept is 3. So over here, we have a point at 3, 0, from our inverse relations. And then we could do our y equals -1/2 x plus 3, switch out our x and our y. And solve for x, for y. So we get value. Let's do this as we multiply by 2 each side. And then let's just y. So this is our new y-intercept, our new slope, but we know that we have our inverse relation at 3, 0. So here's 3. The y equals 0, so here's our point. And we have our y-intercept now at Calculus 6, this would be negative 6. Sorry, my paper has different information than logic would state. Here. Y. Two. Yeah. Okay, for the sake of this example, we're going to put negative 6. This should be negative 6. I'm not sure where my mistake was. Okay. But the inverse relation is still the same. This is negative 6. So it flips and reverses. I'm very sorry that I don't know where I missed my negative from my math.
Well, that's why I tried looking at it too. I didn't see it either.
Yeah. Sorry about that. And it has a different, my number 27 that it starts with, has a different line than my answer key. I'm not sure the translation there. However, if you stick with these 3 general inverse relations, you should be able to graph it by doing the equation, by switching your points, and by verifying that that they do come out to be the inverse of each other. Okay. Do you have any questions for me? Sure. For 3 and 4? Okay. Do we have any questions online? No? All right. Is it okay if I erase some of this and do a quick one? I do need to wrap up. We can go over one more together and we can end the Facebook Live session. Thank you.